students, and like 25% of them got it wrong because they plugged in 3 instead of 1/4, right? Okay, so how do you do this? If you use the tangent line, so what do we need to find? The tangent line, right? What's the equation for y minus y1 is m times x minus x1? So what do we plug in? What do we know already? Or do we know anything already?
We know that we have to.
You need 2 things to write this equation. You need a point and a slope. Do we know the point?
Yeah.
Do we know the point? Yes, we do. What's the point?
0 and
400, right? Exactly. Exactly. So no, y minus 1400 equals m times x minus what? Or in this case, we could call it w, right? And t minus what? 0. So what's the only thing we need to find? M. And how do we know? We know m is dw dt at time what? T equals 1/4, or t equals what? 0. Okay, at t equals 0. Nice. This is going to be equal 1/25 of 1400 minus what? 300, yes. I'm not asking rhetorical questions. I just want to see if you guys are actually looking at what I'm doing, which I'm proving to be either not true or you don't want to talk to me today. But it's okay. It's fine. I'm good talking to myself. It's okay. 1200 over 25. And when you see things like this emerge from free response questions, is that a good sign?
1100.
Oh, I can't do math, apparently. Okay. 1100 of that. So it's going to be 4 times. So what do you get? 44? So what do we have here? We have w minus 1400 equals 44 times t like this. Is that correct? Is it 44? I think it's 44, right? 40 times 25 is 1,000, right? 44. Nice. So what is it asking? It says to approximate the amount of solid waste at the end of the first 3 months. So t is equal to 1/4. So we know that w is equal to 44t plus 1400. So we want w when t is what? 1/4. So is it a nice thing when you get numbers that divide evenly nicely like this? Yes, it is. It's really nice. So you end up with 1,411. Nice. Finding the second derivative. Kids, someone tell me what the second derivative is? 1/25. Equals what? 1/25. Is there anything else to it? Nope, there isn't. Okay. What is this? What do we care about this number? What aspect of this number are we looking for? Is it positive or negative so that we can tell if the curve is concave up or concave down? This is greater than 0, therefore it's always what? Concave up. What does that mean? Therefore tangent line is always what? Line is always what? Yeah, always under the function. So therefore, this is a what? Underestimate. Yay! Okay, we're cruising. First thing you have to do, or they get real cranky on you. You have to separate your variables. So what do you end up with? dw over what? dw over w minus 300 is equal to 1/25 what? dt. So then what do you do to both sides? Integrate. So what do you end up with? ln of what? Minus 300 is equal to what? Plus what? Or c, right? Just a constant. You're absolutely right, but just a constant. Let's call it that for now. So then what do you have to do? You're not done, right? What do you need to isolate at this point? You need to isolate w, so you have e to the 1/25 t plus c equals what? W minus 300. Why are we allowed to drop the absolute value at this point? It's always going to be positive. Why do you know it's always going to be positive? What did it start at? How much waste did it start at? And is it always going up or down? It's always going up, so that thing's going to stay positive. It's good to just keep that in mind. So then we have this a e to the 1/25t is equal to w minus 300. But when t is equal to 0, what does w equal? This is the initial condition they gave us, right? When t is 0, w is what? 1400. So what does that allow us to find? So a e to the 0 equals 1100, like this. So what does a equal? 1100. So what do we have here? We have 1100 equals 1100 what? E to the 125 t equals w minus 300. So what do we have? W equals 1100 e to the 125th t plus what? 300. Now the only thing you want to really check for is, did we answer exactly what they want? Is this what they wanted? Is this the particular one? I think it is. And there, write the first 4 non-zero terms of the Taylor series for sine x about x equals 0, and write the first 4 non-zero terms of the Taylor series of sine x squared about x equals 0. Okay, that's nice.
Looking at x squared factor.
Exactly. So x to the 6th, 3 factorial plus x to the 10th over 5 factorial plus x to the 14th over 7 factorial. I think that's a 2-pointer. That's about as straightforward as it gets. Like, that's, here's something you have to memorize, and we're asking you for it directly. Nice.
X squared
Over.
Minus x.
I think it's always minus, right? Yep. Plus what?
x to the 4
Over. Minus what?
x to the 6
Over.
factorial.
Do we agree with this? It's the first 4, and then you do use this series and this series for sine x squared to in part A to write the first 4 non-zeros of the Taylor series of f. So what was f here? F was, oh look, you add them together, right? So you're doing sine of x squared plus cosine of x. So what are you going to end up with? 1 plus x squared minus x squared over 2 factorial, right? Plus, or sorry, plus x to the 4th over 4 factorial. I'm just going up the powers here. So which you have to, the trick here is you have to make sure you keep track of everything. I just did this and these two because these two are going to combine into one term. And then I did x to the, oh, there's an x to the 4th right here. So what's the next power that's in there? X to the 6th, but how many of those terms are there? So you have minus x to the 6th over 3 factorial, minus x to the 6th over, and you have to have all of those in there. Are you done yet? No, you have to simplify this. So you have 1 plus what? X squared over what? 2 plus x to the 4th over 24. They kind of like you doing at the factorials. And then this is going to be minus x to the 6th over 6 minus x to the 6th over, what's 6 factorial? 720? 720, right? So then what's the first 4 terms? 1 plus x squared over 2 plus x to the 4th over 24 minus x to the 6th over what? 726?
Minus 121.
Wait, why do you have...
No.
All of you got it wrong because you tried to like do something crazy like repeatedly differentiate, right? What's staring you right in the face?
That's
6
Yeah, f, so in the Taylor polynomial land, when you have x to the 6th over 6 factorial, what's sitting right here?
coefficient.
The coefficient is this, right? So this right here, this right here is what? That is the 6th derivative evaluated at 0. What's the most what do you think the most common wrong answer for this is?
1 over 6.
121 over 6 factorial. So they get people like, oh, it's the coefficient of x to the 6th. It's not the coefficient of x to the 6th. It's the coefficient of x to the 6th over 6 factorial. Does that make sense, everybody? Yeah? Okay.
Less than or equal to
Yep.
m over n plus 1 factorial
Yep.
times absolute value
Of.
x minus a
Yep.
to the n plus
To the what?
1. N plus 1.
But then what is m? It's capital M, right?
Yeah. And then
You have to remember what m is, right? What is that?
it's greater than or equal to absolute value of f to the n plus 1 factorial
Like this? At
x.
x, right? Okay. So what did we just figure out? We just figured out we went to 1/4, right? And we know that that's definitely what? Less than 40. It's definitely less than 40. So right here, we know that this number right here is definitely what? Less than 40. So I'm just going to do this. We have a number, so we can keep track of it, less than 40, right? And what's going to go in the denominator? N plus 1 factorial. So in this case, what's n plus 1 factorial? Or what's n in this case for this problem? 4. So what's n plus 1? 5 factorial, right? And then you have 1/4, right? Because that's the x value you're at. What's it centered around, this Taylor polynomial? I think it says 0, right? About 0. So it's 1/4 minus what? 0 to the what power? To the what? To the 5, right? So when you do this out, what do you end up with? You end up with, so you have something less than 40, right? Over 120. And then you have 1/4 to the what power? To the 5th power. So what do you need to show? So you're trying to show that this right here, what was it? It was, they wrote it a little differently. They wrote it P4x, not P4, sorry, not x. What is it, 1/4?
Yeah.
Minus f of, you're trying to show that this right here is less than what? 1 over 3,000, right? That's what you're comparing it to. So what do you have to do to this? What should you this is not a calculator question, right? This is not a calculator question. So so if we do that, it's nice to choose 40 because then we can start canceling things out a little bit. This turns into 10 over 120 times 1 over 4 to the 4th power, right? And then this goes away, and then what do you have?
1/12 times 1 over
Because you go, I canceled one of the 4s.
256.
So we have 1 over 12 times what? 1 over 4 to the 4th. What is 4 to the 4th? 256. So you have 1 over 12 times 256. And yeah, that's not like the nicest thing to do, but what do you have here? 12 times 256, 1, 2, 10, 11, 1, 4, 5, and then you have 0, 6, 5, 2. So you have 2, 7, 3, 0, 7, 2. Oh, look at that. So you now know that you've just shown that P4 1/4 minus f of 1/4 has to be less than or equal to 1 over 3,072. What does that mean? It definitely is less than what? 1 over 3,000. Excellent. Excellent, excellent. Next term. Next term. The key thing to remember is next term.
An equation.
And you have to remember this. M over n plus 1 factorial times x minus a to the n plus 1. You have to remember this. You have to remember that where this right here is the next term. It's really common that they'll ask you this because this is definitively a BC topic. Definitively.